Mm, mm. Hello, student. Welcome to our physics discussion, that is physics in a smart way. In our last video, we had developed parallelogram rule. Already, we had gone into the list of analytical methods, and the very first analytical method that we have considered is parallelogram rule. Okay, just a minute. That is not the proper diagram. Let me do it. So in the diagram, we have shown two vectors. One is A, vector A, other is vector B, and they are kept in such a fashion so that the resultant of them is readily available. So as you very well know, they have to be in the fashion head tail like this. Okay, and as you know that R is the sum of A and B. To find out the value of R, we know already we got the parallelogram rule, that is A magnitude square plus B magnitude square plus twice A dot B, I'm sorry, twice A magnitude into B magnitude into cos of angle between them. Okay, we have to have another diagram that is separate, where we show A vector, we show B vector, and the angle is most clear cut. Okay, that is A vector, this is B vector. Okay, angle, we designate it as theta between them, and if we want to show the angle, that theta here, theta will be like this. Angle between the two vectors is angle between the directions. Let us say we consider a problem or a question. A vector magnitude is given, that is 10 units. Okay. B vector magnitude is given, that is, say, 6 units. Angle theta is variable. No particular value of theta is given. That also means theta we can adjust as we like, as per the situation. The question asks us, find the maximum. It's a simple question. Maximum and minimum possible possible magnitude or value, as you can say, of the resultant. We know that is only possible when you make theta variable. If you make theta, give a theta a certain value, just like A equal to 10, B equal to 10. Once you mention A equal to 10, B equal to 10, we cannot be able to change it till we are out of this question. So if theta is something specified, then resultant will be coming at a particular value, as you know very well. So here the question clearly mentions or clearly hints that you can vary theta as you like, but you have to create a case where maximum and minimum possible value of the resultant will be coming in. So now we go to our approaches. Solution. I think the question is there. If you go to the solution, then we know, let me clear up some space. Solution can be first way. A student can pick up the formula. Whatever may be the case, resultant magnitude will be a square plus b square plus 2ab into cos theta under root, everything, okay? So if I am going for the maximum value, or maximum we say, we are going for the maximum value, we know because a is given as 10, a cannot be changed, b cannot be changed, 2a, b, they have to have the fixed value. Only thing that can be varied is theta and cos theta here, okay? So obviously we understand that when cos theta assumes its maximum value, automatically resultant is maximum. So we now try to search an angle from 0 to 180 degree, and within that range of angles, we try to find out when cos theta is maximum. And we know the answer that cos theta is maximum when theta equal to 0 degree. There, cos theta assumes its maximum value, that is equal to 1. So under that condition, our maximum will be, that will be a square, a is 10, sorry, a square plus b square plus 2a into b, and at that time cos theta is 1, that remains hidden. A square plus b square plus 2ab, that is a plus b whole square, and root of that, obviously you know that is literally the sum of a and b. Magnitudes are a and b, because magnitude of a is 10, b 6, that is equal to 16. Okay, so resultant maximum value will be 16 unit. Under no condition resultant is to exceed beyond this 16 value. Okay, similarly, if you go to R minimum and employ the formula, you know, obviously, that at that time cos theta will be assuming its lowest possible value. So for lowest possible value of cos theta is -1. So for R minimum, we know cos theta must be -1. For that, theta equal to 180 degree and cos theta is -1. So thereby, we do know that R minimum, if you substitute theta equal to -1, will be root over of, that is a square plus b square. And because cos theta is -1, the last term becomes -2ab. That obviously it's the thing within the square root is a minus b whole square, and square root of that will be equal to a difference b or a minus b. Their magnitude difference, a is 10 and b is 6, that obviously will be equal to 4 units. 4 unit. So now you know, and our procedure was to employ the formula, to employ the relationship that we just obtained. The resultant under any condition will be lying between these two values. The smallest is 4 and the greatest is 16. Okay. Now, so that is one of the approaches. A student tries to think like this, that is second way. But let me clear up some space. I clear up the space where the question was occupying because we understand the question, its meaning and what is asked for. So let me clear up this space. We need to have some free space. We do know in this diagram where we show the summation in the so-called vector triangle, when theta is varied, the resultant is varied. Let us say A is fixed. To change theta, if we start to move and A and B, rotate A and B at the same time, that will be creating complication. Okay, so we fix A as it is in its place. We don't try to tamper with that. We don't try to shift. We don't try to rotate it. We fix it. We clamp it down. Then start to change theta, start to rotate B so that theta can be changed. As you can clearly see, when I decrease theta, then B will be shifting its position. Obviously, the resultant will be assuming a new value. ऐसे करते करते, if you do like this, if you get B lower and lower, turn B in a direction like this, we can clearly see that resultant is increasing. Ultimately, the last case will be when B lies flat on A. At that time, resultant will be maximum. Because if you turn B further, we know resultant again decreases. If you turn B further, B is going, head of the B is going to the fourth quadrant. So again, resultant will be decreasing. So the maximum value of the resultant, as it is clearly seen, will be always, as you know the rule, from the tail of the first vector to the head of the last vector. Because A equal to 10 and B equal to 6 will be literally the sum of A and B. So R maximum equal to 16 units, we know. So that happens when A and B, they lie like this. And under this condition, angle between A and B will be your 0 degree because they are the same direction. Angle between two lines which are parallel is always 0 degree. So thereby, A and B, under that condition, A and B, they create the maximum resultant, and the maximum resultant is literally or is the sum of their magnitudes. Okay. Similarly, if instead of decreasing theta, we turn B in the opposite direction, we turn B anti-clockwise. So now B that rises up. So if B is assuming this position like that, we know the value of the resultant is gradually decreasing. Resultant is always from the tail of the first vector to head of the last vector. So as angle theta increases, theta is initially, let us say 10 degree, 20 degree, 30 degree, 90 degree, 120 degree, 130 degree, resultant still decreases. In the extreme case, we know resultant will assume the minimum value when B lies flat on A, but in the backward direction. So at that time, A and B will be assuming their postures like this. An angle between them, and how much is that resultant? Resultant is always from the tail of the first vector to head of the last vector. Because A magnitude equal to 10 and B magnitude equal to 6. So obviously the minimum resultant will be 4, as you have found it using the formula. Okay. And at that posture, or in that posture, under that condition, how much is the angle between A and B? Angle between the two vectors, we know angle between the directions. That is the direction of A towards right. We have to turn from that and go to the direction of B. And at that time, we have to turn 180 degree. That means the value of theta. So as you can clearly visualize, if you decrease theta, resultant is increasing, increase theta, resultant is increasing. So thereby, intuitively, we guess about the resultant magnitude and we find the maximum resultant equal to 16 units and minimum resultant equal to 4 units. So these are two different styles of looking at the thing. If you ask me what is the better style, then my choice will be the second one, because second one is intuitive. It's intuitive, okay? That doesn't mean the past approach is wrong or something is wrong with the past approach. In the past approach, we have taken the formula on the basis of cos theta we have found out. But second way gives you more visualization, and that is more in the way of physics. So thereby I will advise you to go for this type of thinking, this type of solution that is intuitive. We should not forget the formula. Formula should be with us, but at the same time, we cannot be over dependent on the formula, because we are depending on something that is more than normal. Then you can be in a fix, you can be in a problem. And this type of intuitive thinking, intuitive approach, where you visualize the situation, where you see the resultant is increasing, decreasing, that works better, or that works in a long way in establishing yourself in physics. So my basic motive was to help you the way of thinking that one must use in physics. Nowadays, we are having some books, we are having most of the teachers, they're in the past way. In the past way, I do not want to be scandalous, or we should not talk against somebody. But if somebody is forcing you, maybe book, maybe teacher, to go in the fast way only, then there is some serious fault with the things. With the things, intuitive analysis and all that, they are the best approach. They are the best approach. That doesn't mean every time you go for intuitive analysis, sometimes you have to fall back on the formula. So both the things, but we cannot allow our intuition, that thing I used to say as common sense. I sometimes say as common sense, to go into thin air and depend heavily on the formula. That will be again the spirit of physics. Okay, so that was my more basic motive. So in this, or at present, we have gone through the first analytical method, that is cosine rule or parallelogram rule. In my next video, we'll be going to second analytical method, that is your rectangular component method. That is rectangular component method. That's a very powerful way, component method. Okay, why the need of this method, you may ask. Already I know the resultant formula and all that. No, we have done one mistake here. That is, it's not a mistake, it's something is overlooked. After you go through a method, after you go through a procedure, once you learn a new thing, you do one thing, you must consider it pros and cons. What are the pros and cons of the method, how the method can be useful, and in which way the method can be detrimental to your cause also. Those things we'll be discussing in my next video. So thank you for today. In my next video, we shall discuss all those things. If you like the video, and if you feel it is of some help to you, then go for liking my video, subscribe it, and share it amongst your friends, because knowledge is there to spread. And if you spread it, then we'll be getting more and more.